Hi, my name is Alexey Medvedev. I'm a chair of Khronos 3D Forum working group, and I'd like to present our not guest presenters today. And we want to give you the sense of evolution of 3D on the web, and basically give you what we are working on in the glTF working group. So we have Leonard Daly, and we have Dwight Rogers and Amit Lalish. So please welcome, and let's start. Surprisingly, I don't know what to say in this last slide because I was supposed to actually drive the other ones, but yeah, just overview. Yeah, we present today glTF and 3D Commerce, two groups actually, and before that was a lot of, I think, presentation from OpenXR. Also, we cover the Metaverse Standards Forum as well, so we actively participate in those. Oh, yeah, that was supposed to be the slide. Yep, so yeah, we have the names here and faces. But you can see us. Yeah, I'm in the fog, yeah. I'm in stealth mode. And an agenda today, yeah, we're gonna present the updates for PBR, for geospatial, interactivity, complex scenes, physics, and tutorials. And let's start with
PBR. Yeah, we were actually just talking about this more downstairs at AWE, but basically the big thing in glTF these days is that physically based rendering, we've added all of these extensions in order to create basically photorealistic rendering of a bunch of different kinds of materials. And honestly, this little video will be a better description of the kinds of things that you can do with it anyway.
big shout out to Daniel, who was responsible to create this awesomeness. So, thank you.
I mean, I think we're mostly here to answer questions about PBR, so that's what I work on the PBR panel, so we work on all the various extensions. I've specifically been doing anisotropy recently, so that's a new one that's just come into the latest version of 3.js, and the extension's going out for ratification, but we've done a bunch of work on others along the way, so happy to answer questions about what people are interested in.
Okay. Yeah, so interactivity, I've talked about interactivity in several different conferences, but I'm not sure if any of you have heard those ones. What we're looking at doing is trying to find a way to portably represent how content should respond to user actions. And the reason why that's a problem, you might think it's not a problem, because I could just put a glTF content on my website, and then I can put some JavaScript, and my JavaScript could make the content do whatever I want, and problem solved. I don't really need us to solve something. But if I want that content to be portable to someone else's site who doesn't want to run my JavaScript, that's when we start to have a problem, right? And what we're trying to do here is to make sure that if people are creating content that's meant to be portable to various ecosystems, that they have a way of representing interactivity that can work in multiple ecosystems. A lot of people create content in USD, for example. USD currently has two different competing proposals made by third-party companies, which I'm not affiliated at all. But there is a proposal there in USD called Preliminary Behaviors, which describes interactivity in a particular way for one very large ecosystem. There's another proposal, also one that I'm not affiliated with, called Omnigraph, and these primitives also allow you to specify interactivity in some way. And if you are creating this type of content and then you want to send it out into an ecosystem that uses glTF for distribution, we want to make sure that whatever you created in those can be represented in your glTF. You don't lose that information on export, and you don't lose that information on distribution. I've got an example there that we can maybe play of the sort of thing you might be trying to produce with interactivity. This is an example of a configurator where you can tap various things to adjust parts of the bicycle. This is just sort of a mock-up of one of many use cases, but you could potentially imagine a augmented reality experience where you're trying to configure your bicycle and you tap various things to make changes. And then if we go to the next slide, I can tell you where we are right now on interactivity, which is we've created a weekly, what we call a DTSG, that is sort of a sub-working group that works on defining interactivity. And the group almost has the spec, parts of the spec ready for public comment in GitHub. Not quite, but almost ready there. And this was one of the impressive ones. You may have seen this a bit of this in the demo reel, but this was some third-party company looked at the spec draft that we had made so far and actually implemented the spec so far, or at least parts of it, or perhaps expanded it a bit, and created a piece of demo content without us even being involved. So that was pretty cool to see that it's getting some actual traction out there. Even though it's not even in the public comment phase, we're already getting some interest in adoption. So that was pretty cool. We are working on defining a set of nodes that will be available for use in interactivity, and we are expecting that we'll create something that's pretty simple and provides the fundamentals of what's needed, and then we're designing it so that future extensions and vendor extensions can make further extensibility, so that if people want to provide additional capabilities beyond what we author, those can be added into the system. So that's where we are on interactivity, and we can go on to complex scenes, I believe.
Yes.
Cool. So complex scenes, I've got an example of one possible case of complex scenes. This is also taken from the sizzle reel. This is just the idea of what if you have a data set that's extremely large. You potentially have this geometry that is relevant in this particular spot on Earth, but maybe this geometry is only a tiny fraction of geometry that you have for all sorts of other areas. And so how do you deal with that? Potentially, when you have a very complex scene, you may not need all of the geometry depending on where you are, or perhaps you don't need all the geometry depending on what time it is. Maybe you are maybe you're making a scene that lasts as long as a feature-length film, and some character only appears 30 minutes into the film. You don't need to load that at time step one. Or maybe it's interactive. Maybe you don't need to load something until some later action happens. Or maybe you have something very simple, but what you're creating is maybe a mock-up of layout for a house or something of the sort that you're doing, and maybe you have 10 different mock-ups, and most of the components of those mock-ups are in common between the 10 different variations that you're going to give. You want to have some cache coherence in the browser. You want to be able to make sure that if you're using the same tables and chairs, you're not reloading them every time when you load into a GLB. So the Complex Scenes Initiative is trying to look at those aspects of where is partial downloading, where is cache reuse, and where are other things needed in a distribution format. All of these already exist in authoring formats like USD, but right now they're lost when you bake down to a single file for distribution. And so we're looking at how can we make sure that that works smoothly as you export into a glTF distribution ecosystem. And that one is still seeking feedback on how we should resolve these problems. We have some ideas, but we're very much in a feedback stage, not yet in a draft stage, I think, on that one.
Yeah, also the next big extension that we're working on, technically actually there's two extensions. We're trying to cover the physics. And by the physics, actually, effectively, we mean two things. First one is rigid body dynamics. And basically, rigid body, it's like a really technical term that means you have the object which is not modified shape. And the rigid body dynamics explain the behavior, how the object behaves when you apply the natural forces to it. Our goal actually to build like a physics engine agnostic approach. Basically, we want to get the common parameters and expose them and to not depend on the actual implementation on the physics engine. That means we are not reliant on any kind of deterministic physics behavior behind this. And yeah, as the part of the solving the problem, we decided actually to split the physics and rigid body to two separate extensions. One is actual dynamics, and second one is the collision. Because collision is pretty much useful not only for the physics application. So that's one of the approach. And yeah, we introducing the extension for the collision objects that you can describe any kind of convex shapes or the tri-mesh if you need to. And let's see why we need this. Those are a couple examples of the physics. So basically, glTF itself, besides the animation that you can pre-bag, it's pretty much static. So the physics give you the sense of the actual like naturally looking objects. And those demos presents how it works. Currently, those extensions are implemented in Blender and in the couple other engines like Godot. Well, you can try it right now if you want to. Let's go to the next slide. And basically, yeah, those are just like use cases. Collision detection can be used not only for the physics, as I mentioned before, that you can use for the visibility testing or like any kind of intersections that you want to, or like object placement, if you need even probably extend to real world applications as well. And that's the state of art. We do support different shapes, and those are examples of the shapes. The actual shapes, again, can be used for the collision. And that's, I believe, pretty much it. Yeah, as I mentioned already, we have implemented those. We have a list of the features that we want to work on. The extension for the joints that I kind of forget to mention. So we support rigid bodies and the joints. Joints are literally constraints like between the different nodes that you can constrain the movement and the other motion parameters around this. And we're working on advanced shapes. And another really important topic for us is alignment with USD. We want to be interoperable with USD as much as possible. And this is the link if you want to again look at this. So that's the actual GitHub link. Any comments are really welcome. Those extensions are still in development, so it's not too late to change if you have any requests. And I think Leonard is next.
There we go. Okay, so almost 2 years ago, the working group responsible for GLTF decided to form a tooling group to advance tooling in support of GLTF. The group has spent about 6 months understanding what exactly the toolings would be needed, both in terms of promotional and educational material, and then tooling direct support to developers, artists, and engineers. So this represents the rough concept from conception of an idea to build a 3D model to its public distribution. And the boxes in there highlight many of the tools that have been developed or in the process of being developed through the end of this calendar year. Quite a number have been finished off in the last several months, and I'll cover some of these. We'll spend some time in other sessions this week talking about some of these other ones. So the idea is not to repeat anything or not to repeat it much. So come to all the sessions and you can get the full suite of things. So starting at the beginning here in this modeling section, we put together 2 tutorial videos. Actually, it's a long and a short version of the same thing. And I'm not going to play them in full, but...
What is glTF? glTF provides for the efficient transmission and display of 3D assets. It's a leading specification for sharing 3D assets, such as scenes and models, which have been output from 3D content creation tools. glTF is primarily a transmission format. It's been designed and optimized for both delivery and use at runtime. This means that it minimizes the size and processing requirements for 3D renderers, engines, and applications.
So this video and all the other videos will be soon up on the Khronos and YouTube websites. This one will be hitting on the sooner side because it's ready to go. Also, in conjunction with this, and as you saw, there's quite a number of models there. We have just recently finished off developing a new sample, well, it used to be called sample models, now it's sample assets, with the intent of including more than just models. The repository has a full description of the models, including credits, something that we were lacking before, and a clear description of the license. So it's now become a lot easier for people to use either in their own development applications, in their own tools, or just as learning tools. And this is just a small selection of the assets that are available. Many of these have been shown up or will be shown in other Khronos presentations. And so probably look quite familiar, like that tennis shoe and the mosquito and amber. In addition to the what is glTF, there's also this clear coat video. This goes into technical details about how to use clear coat in Blender and how to create 3D glTF models using clear coat in Blender. We specifically developed the Blender exporter. Not for this purpose, it had been developed, and this is why we focus a lot on Blender. Plus, Blender as an free and open source tool is very useful.
With the material selected, I go to Add, Texture, and choose Image Texture. I move the texture object to where it can be seen on the graph. Now I click Open on the texture object and navigate to the saved PNG file called Image Clear Coat. That's the image you can see here.
And again, I'm not going to play the whole thing through. This video is about 5 minutes, and it goes through how if you start with a glTF model ready for clear coat, how you go about applying it, and in particular, and what they're showing right here is how it's not applied to the decals, but it's just applied to the paint. Among the tools that was developed was a tool called glTF Compressor. And this is a tool that allows the reduction of image textures. It allows you to compress PNGs, JPEGs, and KTX. So you can compress to any of those formats. KTX, if you're not familiar with it, is a very useful format in that its size is during transmission is not that much different from JPEG, but it retains the small size when it hits the GPU. So you're not taking up a lot of GPU RAM storing a texture as opposed to JPEG or PNG, which have to expand to its full texture size. And this is the sample viewer. Sorry, I was just describing this one. If you notice that both of these things look like the same interface, and that they are. This is built on the Khronos tool sample viewer. For this particular piece, they added this button here called texture compressions, which allows you to go through and adjust these particular textures. The other project, which we'll cover in just a moment, is also built on sample viewer, and it's to illustrate a portion of what Dwight talked about earlier when he was talking about complex scenes. His example was for geospatial. In this particular case, this is more of a in-room example. If I had planned ahead. In any case, what they're doing is loading multiple glTF models into a single scene. That had not been possible before, and so this is considered development work at this time. And this particular case, when it comes through, will be a table, a lamp, and a vase. But it may take too long, so we won't wait for it. So those cover the particular examples. I'll go back and pick up the other one if it does show up in time. These are the demos I ran. And this is the sample asset. These are backup slides just in case things didn't work. So now we're time for open discussion. So Alexi, how do you want to do this?
Assume we will just wait for questions if you have any. Yes, please go ahead.
Hang on for a second.
I'm
We have
sorry.
a mic.
Yeah, we'll give you a mic.
Wanted to see if you could give me a little bit more color or context on the future of glTF. For instance, are we going to be storing more types of metadata that might take different forms, like blobs, for instance, just to accommodate special software applications? Where do you see the GLT format going in the next let's say 1 to 5 years from now?
So currently, we do have the capability of storing XMP metadata into the scene. I presume you mean beyond what that capability is? Okay, that has not been addressed, at least to my knowledge, but.
Well, so I would say that first off, glTF is designed primarily as an extensible format. So, the beauty of it is we have 3 different levels of extensions. You can put extension data practically any kind, anywhere in the format. And we define vendor extensions, EXT extensions, and Khronos official extensions. And so the idea is that the Khronos official ones were basically saying, look, everybody should adopt these. These should be pretty much universal. You should be able to depend on these existing in pretty much most of the tools. EXT is for things that are kind of more specific to maybe particular industries or use cases. You want to have interchange between different companies, so Khronos kind of helps and gives some vetting to make sure that those extensions are really well formed and that people can interchange them pretty well. But there's a lower bar for kind of getting them published. And then there's vendor extensions, which you don't even have to talk to us about. Anybody can author a vendor extension and put literally anything they want to into a glTF. And they don't have to make that spec available if they're just using it for their own internal purposes. But, if they make a vendor extension and they're like, hey, this actually seems like it would be cool, maybe other people would like this, we make it easy to basically bring those things into the fold and make them available to the rest of glTF users. So I'd say there's pretty much anything you could want to do.
There is some work in the geospatial area regarding metadata.
Yeah, so for location-based, interactivity, let's say, and also for including installation instructions and videos, are we going to be encouraged to embed that kind of data within one glTF file, let's say?
I actually get a lot of questions like this internally at Google for various things different teams are working on. And the thing that I always ask people first is, in your use case, do you want to download a 10 megabyte glTF model before you get access to that metadata? Or would you like to have the metadata available first and use that to decide when to load that GLB? You think about geospatial content, it's a great example. A lot of times you actually want to know where physically this is going to be used so you know you don't have to download it until you're in the right place. If that's true, then you really want that metadata to be outside of the glTF. So
Absolutely.
again, it's important to think about, just because we have a format doesn't necessarily mean all the data you want associated with it should be packed into that same zip file.
Absolutely. And an alternative might even be streaming the data. So one good example, like with Unreal Engine, for instance, you have procedural meshes where you could stream in the mesh data. Do we see that becoming more prominent in the future with glTFs?
Yeah, so that's exactly the type of thing that the Complex Scenes initiative is looking at. Complex Scenes basically tries to add that hierarchy of I get some information to tell me what more information is available and where are the glTFs that I might need, and then downloads each of them separately. So if you wanted to say, for example, in the geospatial case, here is my layout of geospatial things, and here's the glTFs that I'll need at various coordinates, right? First, you download a top level that gives you the information, then you decide which ones you download. Similarly, we could say, here's the top level that tells you when you might need these in time, or here's the top level that tells you when you might need these based on resolution or your position. Or as you said, you could have information that says, well, we're going to download this that's procedurally generated, or we might download this thing that's personalized, right? When this scene is composed, it's composed of maybe this chair and this table, but the painting on the wall might be completely different for you than it is for me, because when I hit that same URL, it redirects to something that's personalized for me, and for you, it's redirected to someone else. So that's where we're looking at that sort of hierarchy of downloading, where streaming would logically also go into that conversation.
Answering the question, what the future? Actually, that's the future. So we are working on interactivity, physics, and complex scene, and extension for PBRs. So that's our kind of primary directions.
Yeah, we should also include that there is active work for audio. Not quite sure what the timescale on that is, but it isn't being ignored.
And another thing to keep in mind is that, we've been bantering around like the concept of a glXF format, which technically speaking looks a lot like a glTF, but there's some value perhaps in looking at sort of a division of purpose between formats. One of the big values I see with glTF is this idea that the Khronos extensions are pretty universally supported. You can bring your glTF anywhere and everything's just gonna kind of work. You don't really, even though we have this extension model for PBR, in practice you don't really have to think about it. In practice, pretty much all the stuff that you're going to be used is supported kind of everywhere. All the renderers work to keep up with that. They're all part of the Khronos group. So it may be beneficial when we get into these really complicated things that not everyone is going to implement because not everyone even can, right? Like a viewer isn't necessarily going to have support for physics. That's just not what it's for. It may be beneficial to split this stuff into sort of a separate format, even though it's technically very similar, just to kind of help with people's understanding of what things are going to be supported where. And that's, I think, something that really the group in general is still working to figure out the details of and to get feedback from the community to make sure that we're coming up with something that's not confusing.
We spoke about different tools to generate the content, and how about kind of consuming that content for AR, VR domain? For example, if you take Unity 3D engine, so there are a few plugins available to import glTF into Unity, right? And there are a few third-party plugins. There are a few from Khronos itself, like GLT Fast and all, which supports additional features like animations and all. And it also supports like exporting scene graph into glTF format. So how about supporting all these new features in any of the samples for those engines? Is that in pipeline?
I mean, we don't own those tools, so it's going to be up to the people who are interested. And I think this is really the key, right? Is like some of these efforts are so nascent that we need to get feedback primarily from those tool makers, right? I mean, I think this was the real key to success in PBR, which has been sort of the bread and butter of glTF to this point, is that the PBR working group is mostly made up of the rendering experts who are maintaining the open source and popular renderers out there. And the reason that those things are getting adopted immediately and looking good is because those people are all in the room talking about how to do it well, making sure that it's implementable, making sure that it fits the use cases. And so by the time those specs are hammered out, we're not going out and selling them to somebody. We've already know that the renderers are on board to implement them. And in fact, usually they're already implemented. And really what we're doing is we're detailing the specs of exactly how those numbers that they already use should be represented. And so I think that when we go into these future things, that we really need to follow that same technique. We need to get those people who are going to implement this stuff or who want to implement that stuff into the room to make sure that they are guiding the spec process so that we know that they're on board to actually make that stuff happen.
Sorry. Yeah, so in a previous session, it was mentioned that it's not only kind of poly count, but also size of the PBR, which impacts the performance, right? So now most of the thing rendering, we are talking about rendering on like desktop or laptops. So how about importing this and rendering on HMDs, like HoloLens, Quest, or those devices? Is there any performance analysis done which says like what size of PBR or polycount will not impact the FPS of on those devices?
I probably can answer from meta point of view. Actually, it's a friendly format for mobile as well. So the metallic roughness and probably most of the extensions are kind of fit pretty well to mobile. Well, it scales pretty well as well.
One of the slide, it was shown that Neil Armstrong suit, right? So that is quite heavy. So it's like around 100 Mbps or something. So on the mobile devices, performance is going to impact with such models.
If you want to.
Yeah, so I mean, glTF is absolutely designed to be great on mobile. So I maintain the model viewer project, which is built upon 3JS, web rendering. You know, I can't tell you how many people at Google have told me, oh, well, you know, we could probably do this in a native rendering engine, but like, I don't know, on the web. Well, it turns out, actually, the web has come a long way, and it's just as performant as native. And we can do incredible things with the modern GPUs on a mobile device, and even on terrible GPUs from old mobile devices. We put a lot of work into making sure that Model Viewer can render on everything, all the devices, all the browsers, everywhere. And that includes the various fancy PBR materials, and it includes that astronaut. And the key, again, being that you need to optimize the model. That's the key issue. So for instance, if you go to modelviewer.dev, that astronaut is the front and center thing, and you can try it on your own mobile device, and it's beautiful and smooth. I think that model comes in around 7 or 8 megabytes, if I remember, because we optimized it for web rendering and for the screen size. The idea that you would be making use of millions of polygons when you're only looking at a screen that has so many pixels wide, they're just unnecessary. There's no reason they should be in the file. And the key to remember, right, is that glTF is not the authoring format. It is not the master version of the file. It is the distribution format. It is the JPEG. It is the compressed version. You should not be including anything that is not necessary for the use case that you're actually sending it to. So you always have to be thinking about how big am I going to be presenting this model? On what kind of a screen? How close do I allow people to zoom in? All that kind of thing. What quality do I need? And then you have to optimize your triangle count and your texture resolution, all of that stuff. But you find that if somebody's actually gone through the effort to optimize a model, a few megabytes gives you a beautiful photorealistic model. No problem on a mobile device that's highly performant, quick to download. It's just that you have to put the effort in to make sure that that's actually been made ready for distribution.
A dumb question, but you mentioned about looking at the metadata first before actually downloading the model, right? So many times people want to just see kind of thumbnail of the model before actually downloading that. So is that part of standard, or any of the tools does support creating thumbnails, auto creation of the thumbnails?
So again, if we made that part of the glTF standard, it would defeat the purpose. So no, it's not there, and very much intentionally. But you look at something like Model Viewer, right, which is a web component to make it easy to put on your website. What's the number one first feature of that? It's the poster image, just like you have in a video element, right? And that's where you specify your JPEG image of whatever resolution you need. And you know, the beauty is, like, I remember when we got started with that, people said, oh, well, but I can never get a perfectly seamless transition between like an image and a 3D model. I mean, especially if I don't know the aspect ratio of the container, like there's just no way that would work. Well, we did make it work. If you go onto our editor, you can click the button to generate your poster of whatever your model is, and then you put that in, and we guarantee that you can have a responsive shaped website, and we will always give you a pixel identical switch out from the poster image to the 3D model. So your users don't even know when that loading has occurred. You can completely hide the latency. And that's really important when you talk about web development and progressive enhancement and such.
Thank you.
So I have a question for the audience here. Oh, is your hand raised? No. So in particular, are there any pain points or difficulties associated with glTF that you are experiencing that we may be able to solve for you?
Sometimes there's a desirability to switch between different types of renderers. So you have popular ones like Arnold, V-Ray, many various other ones. And it'd be nice to kind of embed parameters that relate specifically to some of those renderers and be able to kind of maintain them in the glTF file. Is that something that's recommended as like a workflow? Because I understand this is more of like a distribution format.
Can you be a little more specific? I'm thinking of lighting and tone mapping, but maybe you're thinking of something else.
I mean, those are valid. I'd include those. You know, specularity, things like that.
So specularity is a material property, 100% represented within the PBR extensions of glTF. So yeah, any material property absolutely in there. And if your programs have support for the Khronos extensions, then you should be good to go. That's what glTF delivers, is that ability to have faith that you will have accurate representation of those physical properties across renderers.
Okay, so in this case, if there are program-specific parameters, like maybe at the shader level, do you recommend just embedding those parameters in glTF metadata somewhere?
So again, the purpose of glTF is to avoid the need for shaders, and therefore for shader parameters. In effect, what we've said is all of the parameters of your shader, however you've written your shader, are represented by physics.
Yeah.
So we define everything that goes into the glTF, whether it's factors or textures or anything else, we define those things in physical terms. And that's really powerful. That makes the format future-proof. That's really the big difference, because now anybody can write any shader they want to create those materials, and they do. I'll guarantee you look at those renderers, they have completely different code, completely different approximations for doing these things, optimizing for various different things, and innovating. And the beauty is we know what it should look like because we understand the physics. You can always go through and do a really slow path tracer that's just following the exact physical equations, and you can get a really trustworthy result. That's the North Star. Every other renderer is just trying to get as close as they can to that while maintaining a 60 hertz frame rate or whatever it is that you need. And because of that, that's the real power, the real difference of glTF from a lot of the formats that came before, where they actually packed shaders in, you know, and, oh, now you're on a mobile device with a different GPU, and oh, sorry, that shader just doesn't work. You know, like, that would be terrible. Now we can have the renderers take care of making the shaders work everywhere. You don't ever have to think about that. You think in physics, and now your same glTF model will only look better as time goes on, because people will get closer and closer to approximating the real world of physics.
Okay. Another question is, do you have a general kind of a CAD or vector-based kind of conversion recommendation going from that format to glTF, like the DWG, et cetera?
you specifically asking about a CAD format or just a general vector?
Going from vector to kind of GLTF type format, like what sort of recommendations do you have going from kind of the CAD world to GLTF?
I seem to recall Autodesk does that.
So my first thought is that if you have to do a CAD translation, Polytrans is probably the first place to look.
Polytrans, yeah. 'Cause you might use other things like Twin Motion, for instance, and then eventually wind up with GLTF.
Yes, there's multiple paths that take you from wherever you happen to be to GLTF. And you want to pick something that's going to maintain the
Fidelity.
accuracy of the data that to a level that you want. Obviously, you may not, if you have a really high level, high-end NURBS curves that describe things in CAD, you're going to have to triangulate it someplace, and so you're going to lose some of the accuracy. And it's a one-way path. But it will maintain something of what you want, what you really need to get out of it. So it's important to know what your end goal is and what's important for that end goal. Polytrans, DGG also has some tools but they may only work once you get down to the triangle levels because they're geometry reduction, geometry compression, which can, when you start from the CAD world, you may end up with multiple millions of polygons. And you got to get it down to something much more reasonable for a deployment format.
It sounds reasonable. Yeah, decimation, for instance, you can do. Yeah.
Nothing left. There's no sense
Yeah,
in keeping
if you have no more questions, probably we can end it earlier, right? Thank you. Yeah, thank you for your participation. Thanks for the questions. And thank our dear guests for participation as well. And yeah.